All right, good day, everyone. This is Mike Montefusco, a meteorologist with the National Weather Service here in Wakefield, Virginia. And this is our basic Skywarn spotter training class. This class is designed to give you the basic weather awareness information, as well as some basic spotter safety tips. This class is designed to give you the latest information that we have, as well as give you the information that we have to get in touch with us. And we'll talk about the importance of our Skywarn spotters as we go through. As we get going with part one here, we'll be talking about the importance of our spotters. Second, we will be talking about the types of severe weather, specifically thunderstorm formation, straight line winds, hail, flash flooding, wall clouds, funnel clouds, and tornadoes. We'll also be getting into in second and third parts of our presentation, talking about reporting procedures before we get into spotter safety. We will have an interactive quiz that we will talk about as we go on as well. So let's go ahead and get started. First, what are storm spotters? Well, specifically, they are volunteers who relay real-time information to us in the National Weather Service. We rely on our spotters to give us information in real time as we are issuing warnings to help keep our community safe during hazardous weather. Very simply, our storm spotters are our eyes and ears on the ground, and that ground truth that our spotters relay for us really help us to insert some credibility and public response to enhance our warnings that go out there. And they also improve our warning accuracy. So what you might see in the community on the right there is going to look like what we see on the left side on our radar display. And our radar display will tell us what we should be seeing out in the real world, so to speak. But what you actually see is going to be the important part of what's going on. And only we can get that truth, that ground truth, from you, from our spotters. So those spotters are very important to give us the context of what's actually going on in real time out in the world. So you go through our radar. This is a picture of our radar at the office here in Wakefield, and what's going on underneath that white radome is what you see here. This satellite is spinning constantly, and it's sampling all the way up into the atmosphere, 20 different elevation samples. And what it's actually doing is it's sending sound pulses out into our clouds. And those sound pulses will in turn bounce off of raindrops, ice particles, and anything else that it could hit. And it'll send that signal back to the radar when it does hit something. That reflectivity, which is what we're all used to seeing on the evening news as we see our favorite television meteorologist presenting the weather, is giving us the reflectivity, or the amount of the signal that's being reflected back. Now those yellows and reds and purples that we're all accustomed to seeing that denote heavy rainfall basically mean that signal is coming back a lot stronger. A lot more of that signal is coming back. And we use that to denote areas of heavy rainfall or ice production or whatever else it could be. But in our practical purposes for this course, we're going to be assuming it's either ice or heavy rainfall. So that's basically what we're used to seeing. But the second piece of it is what's called velocity data, which is basically the direction in which the air is moving. This is what puts the Doppler in Doppler radar. We hear about, Doppler 2, Doppler 4, Doppler 10, Doppler 9 million, what does that mean? The Doppler basically just goes back to what's called the Doppler effect. And what the Doppler effect actually is referring to is the ability of the radar to determine which direction the air is moving. Best real world example that I can give for this is when you're going down the road and you see a train coming. That train, when it sounds its whistle, is going to sound differently in front of you than it's going to sound behind you. And the difference between those is the Doppler effect in action, basically determining whether that sound is moving towards you or away from you. And the radar is able to do that, and that's a powerful tool that the radar has, because that allows us to determine straight line winds, winds that are moving towards the radar versus winds that are moving away from the radar. And when those winds are paired right on top of each other, we have what's called a couplet, where we have winds moving towards each other and away from each other, co-located, and that gets into the potential for tornadic storms or storms that could certainly be rotating. And we'll get into why that's significant as we go on with our course here. There are some significant limitations that are presented with the radar. Namely, if you look at our two storms, location A, we're going to be able to see a lot more of the lower portions of that storm than we will with storm B. And that is due to the curvature of the Earth. Because of the curvature of the Earth, we are not able to see the very tops of those storms in storm A, or the lower level profile of the storm for storm B. So the resolution is going to be poor the farther you go away from the radar. So it's going to gradually degrade the farther you get away from the radar. So at a distance of 100 to 150 miles or greater, your low level resolution is not going to be very good. And because of that degradation, we're going to have some issues with seeing the low level features that far away from the radar, which is where our network of radars comes into play. We have other weather service offices across the country that we can tap into and look at in real time as we need to. And also, obviously, our storm spotters come into play as well to help us kind of fill in the parts that we need to know to let us know what's actually going on in real time. So that part of it is really what comes into our spotters really helping us out and filling in some of the blank spaces. So very simply, our storm spotters help us at the National Weather Service to save lives and property. Our mission to save life and property is a very basic tenet of the National Weather Service, and what we do to save lives and property wouldn't be possible without our spotters helping us out and making our warning operations that much better. So we have some ways that we use to keep our spotters attuned to what it is we're concerned about. Our website is at weather.gov/Wakefield, and it's always there for your latest forecast information with statements and warnings for your safety and to keep you aware of what's going on. So we have a lot of different products that we use to help keep you informed and help you to understand what it is we're looking at and what we're concerned about within the forecast. Namely, the National Weather Service operates what's called NOAA Weather Radio. I can't speak highly enough about NOAA Weather Radio. This is something that I like to call the smoke alarm for weather. It's something that you can test. You go to weather.gov/Wakefield/NWR, and you can get codes for every municipality and jurisdiction within our forecast area. And you can actually program the radio to go off and alert you in the event of warnings that are issued for your county. And any neighboring counties, for most radios, any neighboring counties as well that you specify will also alert. And that's very, very important in terms of having that peace of mind when you fall asleep or when you're not paying attention to the weather for whatever reason. You're going to get that weather alert when you need it most to get that information to you, and then the radio will turn itself off just after it's given you all that information. So it's very important. It's always watching the weather, even if you're not, and it's going to get you what you need to know. Skywarn, obviously this program falls underneath the Skywarn program. All of our course listings are advertised on our Skywarn link at our webpage at weather.gov/Wakefield/Skywarn is the direct access to that. You can download all of our handout information. You can enter reports in real time, as well as get a course completion certificate if you do need that, as well as a host of other services that we have listed for you on that Skywarn page. And then lastly, that briefings webpage, weather.gov/Wakefield/brief. We will give you the tools to brief yourself. Should you like to keep an eye on the weather, we'll have the latest weather model information, as well as all of our text products available for you at a click wherever you'd like to have, whenever you'd like to have it. You just go directly to that website and you can pull it all up as you need it on demand. So this is our hazardous weather outlook. This product is something that we use to speak to our spotters. And our spotters will basically get something like this at least once a day from us, if not more. And it's a layman's type product. This is not going to be the technical discussion that is the area forecast discussion or the Storm Prediction Center as they send out their mesoscale discussions. This is going to be very, very simple. Layman's type terms, just getting into what we're concerned about, what timing we're concerned about it, and where we're concerned about it occurring. So this is going to be very, very simple. Paragraph or less for each day, for day 1 and then day 2 through 7. I want to call your attention to the bottom, the spotter information statement. This says the spotter activation may be needed this afternoon and rainfall reports are welcome. Don't feel the need to wait for the spotter information statement to say that we're accepting reports to give us a report. If you have something that you feel is noteworthy that you want to get our attention for, go ahead and do that, because that's a very important part of our Skywarn process and our spotters. We want you guys to be able to get a hold of us when you need us. So just give us a call. We're going to give you that forecast, that spotter information separately. And we are going to give you all the tools to get a hold of us, however you need to get a hold of us, and report as you see fit. Don't wait to be activated or anything like that. So next we'll talk about severe weather definitions. And you've probably seen the scrolling on the bottom of your TV screen. And we'll talk about a storm that is coming through being labeled a severe thunderstorm. What is that exactly requires a thunderstorm to be severe? Well, we're looking for hail that is 1 inch in diameter or greater, and or 58 mile per hour gusts. It could be any combination of those two things. That 1 inch hail is basically the size of a quarter or larger, or 58 mile per hour wind gusts. We don't issue warnings for lightning. Lightning obviously would be something that comes with most thunderstorms. We are a little bit more discerning than that with our warnings. 1 inch hail or size of a quarter or 58 mile per hour gust is our criteria. Now we have a kind of a 3-step continuum to our watch warning process. Number 1, we get into the HWO, which we just talked about. Second, we get into our watch process. This is the day of the event that's ongoing. We're looking for conditions that are favorable for hazardous weather in and near the watch area. And this is going to be a larger area. You see in this case, we've got something from about the Pittsburgh area, Mason-Dixon line, roughly, into northern and central Virginia and parts of western Virginia, West Virginia. And this is going to be for 5-6 hour period on average. And again, this will be issued by the Storm Prediction Center out in Norman. They'll communicate with us and we'll issue a watch in consultation with them. So this is something that is basically saying that the conditions are favorable and these conditions may develop within the next 2, 3, 4 hours over the watch area. It's going to be a large area, and again, typically going to be for conditions that are favorable later on in the day. When a warning is issued, this is basically telling you that that weather event is imminent or it's about to occur, or it's going on now. This is going to be with warning polygons that are formatted for the area of the greatest threat, and these will be issued entirely within our forecast area, by us here in Wakefield. So these polygons are going to be for half hour, 30 to 45 minutes in most cases at the very most. In the cases of very slow moving storms, it could be up to an hour, but that's typically the timetable. Much less shorter in duration than a watch would be. We do have the ability to issue what are called tornado emergencies. Now, this is something that when we have a large tornado that is confirmed to be on the ground and doing damage, we have the ability to issue a tornado emergency for those storms. So Hopefully the need never arises, but should the need occur, we do have that ability. Now, for storms that don't quite meet that criteria for severe weather that I talked about, quarter size hail, 58-mile-per-hour wind, we have what's called a special weather statement. These are issued for thunderstorms that aren't quite to that criteria for severe storms, but are nonetheless notable, strong to almost severe. So in this case, we got a line of strong thunderstorms that are affecting the Richmond metro area in Virginia. Wind gusts to 40 miles per hour and small hail are possible with these storms. Frequent lightning are also expected with this line. Now, these are storms, again, that aren't severe by the book definition, but certainly are notable, will get your attention as they come through, and could potentially be something that makes an impact with respect to making navigation difficult, or lots of hail, or those damaging wind gusts could knock some smaller tree branches down, or tree limbs down. Not quite to the severe levels, but something that'll certainly get folks' attention. We will put out an SPS for that reason. In the summer months, we will also tend to be issuing these for storms that are producing a lot of lightning. We don't issue warnings for lightning, but we do issue SPSs for lightning. So when we get into the summer months, when we have our storms that are just producing some very heavy rainfall and lots of lightning, we'll issue an SPS for those, just to kind of let people know, hey, this storm is very electrified and producing a lot of lightning, and stay indoors. So just we'll give a heads up for that, and those will typically be alerted via social media. So if you're following us on Facebook or Twitter, you'll see those alerts go out graphically from our social media feeds, just letting people know, hey, these are pretty strong storms that are coming through. They might not be severe by the book, but they're certainly going to get your attention as they come through. Now, these Skywarn classes are a good way and a good time to think about how you receive warnings. There are obviously multiple ways of receiving warnings, but thinking about how you receive a warning in particular is important. So certainly while you're at home, while you're in the car coming home from the gym or from work or what have you, how do you get that warning information should a storm come through? How would you find that information? Certainly our tornado warnings are issued by our wireless emergency alerts. So they come through our cell phones now. But beyond those, we have our weather radio. We have our webpage at weather.gov/Wakefield. We have our friends in the media. And all of those alert tones that you hear also come over through the emergency alert system, will come over your radio. If you have terrestrial radio, it'll come over your radio. So when you're listening to the local radio, the FM radio, the AM radio, you'll hear those warnings go out over some of our radio stations. So you'll get those in the car as well. So just kind of figuring out where you get our warnings, how you hear our warnings, and how to keep yourself safe during those times. All right, so we'll talk a little bit about thunderstorm formation as we wrap up part one, or get into part one here, I should say. We'll talk about thunderstorm formation. So our three ingredients really come down to moisture, instability, and lift. So think about a warm summer day or a warm spring day, and we start the air heating the surface of the earth. And as the surface starts to warm up a little bit, late morning, early afternoon, as we get into the day, the air starts to get heated, and as that air gets heated, it starts to get less dense. And as air becomes less dense, it wants to rise. So if we have enough moisture present, we'll have those puffy cumulus clouds start to form as you think of your high school science class. So think of our puffy cumulus clouds, those little cotton ball type clouds that pop up. As our air becomes lighter and start to rise, we're going to start to elongate our clouds and stretch them into the vertical. And as that happens, we're going to get what's called the towering cumulus cloud if we have enough lift. We're going to be able to get what's called the towering cumulus cloud, and this is all updraft. This is all inflow, air going up climbing within our developing thunderstorm. And as that source of lift gets going and kickstarts our updraft, and that gets our thunderstorm development underway as well. So our mature thunderstorm is when we have that symbiotic relationship between the updraft and the downdraft. I want you to see the top of the storm here, in this case upwards of 40,000 feet. We have our very top of the storm. This is what we call the equilibrium level, or EL for short. And that tends to be where our instability goes away, where our lift is going to cease because we get back into equilibrium. As Newton tells us, we can't destroy energy. So what happens is when it gets to the top of this storm, it's going to make its way back down towards the ground. And when that air starts to make its way back down towards the ground, it's going to start to cool down as it sinks. And that's going to produce our developing rainfall area. So as we get that downdraft going and get our air starts to move back down, our downdraft makes its way back down to the ground. This is where our heavy rain and wind is going to be. Now you'll notice this little pink dotted line denoted by the 32 Fahrenheit 0 degrees Celsius line. In the updraft area, it's actually going to be lifted upwards, dislocated upwards in the vertical. That's actually because we have warm, moist air that's buckling it up. And in the downdraft area, we have it displaced downward because we have our cool, moist air displacing it downward in the vertical. So this is our symbiotic relationship between the updraft and the downdraft. This is a fully developed thunderstorm with that updraft and distinct downdraft area. Now you'll notice the updraft denoted by this yellow arrow. We have a lighter background behind it. This is what we call the rain-free base. There really isn't anything in the way of rainfall in this area because we have air going up into our storm. So it's basically taking in air, if you will, or lifting up air. Whereas the downdraft is coming down in the green area, and this is a darker sky behind it because we have our heavy rainfall and any wind coming down from our storm. So this is our outflow, where our storm is actually pushing out air out of our storm. So this is the updraft area in the yellow, and the downdraft is in the green. So we have our moisture, we have our instability, we have our lift. Next, we're going to talk about the importance of wind shear. For a thunderstorm to survive, we need wind shear to keep the updraft and the downdraft separate. Now we have two separate types of wind shear. Number one, we have speed shear. Speed shear is defined as the increasing of wind with height. Secondarily, we have the directional shear, which is the changing of wind directions in the vertical from counterclockwise from about 5 o'clock on the clock face to about 11 o'clock on the clock face. So for a thunderstorm to survive, we need wind shear to keep the updraft and the downdraft separated from each other. So in this case, we have our speed shear and we have increasing wind with height. So at the surface, we have lesser wind than we have as we go up into our storm. Now, if we don't have that wind shear, if the wind shear is not present, well, as we know, or anybody that's been around here in the summer months, or anybody that's in the state of Florida for pretty much any time, can tell you basically will have a storm that collapses on itself and dies. It'll rain for about 2, 3, 4 minutes at a time, and then the updraft will just kind of collapse, or the downdraft will just kind of collapse on itself, and the storm will just rain itself out. And it'll just very quickly just kind of poof, it's gone. And that's what happens when you don't have the wind shear present. The storm is very disorganized and it doesn't last very long. Now we have 4 different types of storms, and from the upper left to the lower right, they increase in severity as we go. Number 1, we'll talk about the single cell. That's basically like we just talked about, rogue storms kind of on their own. That'll kind of pulse up and pulse back down. That will very quickly tend to rain themselves out. The multicellular line is really nothing more than a line of storms or an area of storms in multiple stages of development. So you could have a developing storm next to a weakening storm, or a weakening storm next to a mature thunderstorm, some combination thereof. And it's just kind of several different thunderstorms kind of merged together within a cluster. The squall line typically will be the leading edge of a frontal system coming through. This will typically be, again, like a derecho type thing. We'll talk about the derecho in a moment, but typically like a front or a long line of storms coming in. And lastly, the supercell, where the supercell will be rotating as it comes in, which we'll talk about in part 2 here. But the supercell has an extra element of danger to it because of the intense amount, or the great amount of shear that it has available to it. It is actually rotating before it becomes severe, which adds an extra element of danger to the whole situation. So this is our squall line, and this tends to be, again, the leading edge of a strong front that comes in. If you get warm, in this case early April, we have a warm air mass ahead of a strong cold front coming in from the west. Typically you'll have a strong squall line when those things occur, which basically leads to this long line of storms that typically will be denoted by damaging winds. Damaging winds will be your primary threat with these squall lines. They'll often be accompanied by what's called a shelf cloud. The shelf cloud is going to be present in pretty much all thunderstorms, but it might not be as picturesque as this in most cases, but in a lot of cases, I should say. But what the shelf cloud is actually this elongated cigar-shaped cloud on the leading edge of a thunderstorm. And the strong damaging winds actually come from underneath the shelf cloud out of the screen. So as you're watching this storm, it's coming out right out at you. And the worst is going to be first with these squall lines. You're going to have this come through, and that cool burst of wind that you think of when a thunderstorm is arriving, that's what you get with our gust front coming out of our thunderstorm, immediately followed by the heavy rainfall that comes with our squall line coming through, and then the wind and rain gradually will diminish as the storm moves through. So again, our strong winds are going to accompany the shelf cloud. The winds are going to be towards the storm until the storm is up on you. So at the very lower left of this image, our air is going to be going in towards the shelf cloud as warm air going into the thunderstorm. And as the thunderstorm comes in upon you, the wind is going to very quickly turn around, and you'll get that cool burst of air once our thunderstorm arrives, as that gust front pulls into town and changes the wind direction, typically, pretty sharply as that thunderstorm comes through. Storm motion is from left to right. So as we have this squall line coming through, this is a very telling video with the squall line coming through. And you can see the shelf cloud forms with strong winds coming in. And if you watch just about that co-op in the center of the screen, you can see that we have a pretty good dust cloud coming through. And this is what a gust front is going to look like. You'll just have that wind going into the storm until the storm actually comes up on you. Then the wind's going to turn around. You'll get that gust front coming out of our thunderstorm. And the rain-cooled air is coming out right behind it. So we'll get into supercell thunderstorms in more detail in the second part. But here in part 1, we'll talk a little bit about supercells. They'll produce typically some pretty large hail. In this case, we've got quarter-size hail. And the thing about supercells is they are most likely to produce severe weather when they are present. The reason for that is we have some very strong shear with these storms when they come through. And as a result of that shear, the storm is going to be rotating as they come through, or as they develop. So before they even become severe, they are already rotating thunderstorms. So as the result of that, we have the ability to get these storms pretty significant and pretty strong before they even actually reach severe limits. Um, what is actually tightening that spin as they go is the rear flank downdraft here in the lower left. That's kind of comparable to you take a pool of water in the bathroom sink and you just kind of spin it with your finger. When you do that, you're tightening the spin. You're kind of creating spin within that bathroom sink. The rear flank downdraft is doing a similar thing in that it's focusing and tightening the rotation within our thunderstorm. And that rear flank downdraft is actually serving to tighten that spin, and that little whirlpool that you get in the bathroom sink, that tends to be a little rotating whirlpool, if you will. What happens in our thunderstorm is that kind of develops a funnel cloud, which could turn into a tornado eventually. Now you look at the classic Supercell schematic, and you have this hook echo. And the hook echo will basically be a little cluster of storms that winds up getting curled around by that rear flank downdraft. And that's going to be denoted by the bounded weak echo region, which is right in here at the triple point where the warm front beats the cold front in this radar example on the right. And that is where your tornado is most likely to be. So you have your flanking line coming down on the cold front side, and then on the stationary front side we have some pretty heavy rainfall right along and north of the bounded weak echo region, or BWER. That's denoted by the T in our tornado. So this area with the T, that's where your tornado is going to most likely to form. So as far as where your best location to spot is, typically in the lower east side or southeast side, something like this, you'd be able to see a little bit more. If you're back in the northern part of this picture, you're not going to be able to see a whole lot. You'll be able to look at just dark clouds because of all the heavy rainfall within the forward flank. You're not going to be able to see a whole lot if you're on the northern side of the system. And if you're behind it, you'll kind of be looking into the storms as they depart. So to see much of this storm, you'd probably be able to be where this storm is in the lower right corner here. So for hail production, we talk about hail production, and the bigger the updraft, the stronger the updraft, the bigger the hail. And we say that basically because if you think of, say, the lotto drawing on the evening news, you think about the little ping pong balls bouncing around in that clear tube. And what's bouncing those balls around is you have an air pump underneath it pushing those balls up. What happens with the hail is kind of a similar process. Basically, the stronger the wind is vertically, the stronger our updraft is, it's basically going to be able to hoist our ice nuclei higher for longer within our thunderstorm, and therefore the longer it's up above the freezing line and bouncing around in our thunderstorm, accreting moisture and getting bigger and bigger, the more we're going to have severe hail. So basically, the longer those stones are up there rotating and accreting moisture, the bigger those hailstones are going to be. So the stronger the updraft, the bigger the hail. When you get into those type of situations, our storms will tend to take on a greenish hue. For anybody that's from the Midwest especially would know that. Those green skies tend to be a harbinger of some pretty big hail, or at least storms that are full of hail. And that's kind of an offshoot of Rayleigh's scattering, which basically means the light passes through all the ice within our thunderstorm, and the thunderstorm has a green look to it as it comes through. So a lot of folks will kind of tell you when you see those thunderstorms with a green tint, yeah, it's time to get indoors, because that storm means business with respect to the hail. So the dangers of hail should be pretty obvious, but hail can damage vehicles, crops, and structures, and can lead to hazardous driving conditions, certainly. This is a video from a beach where folks are just kind of seeing a storm coming in and very casually getting out of town. And this can come on you pretty quickly, especially if you're not paying attention to the weather. This can get you into trouble pretty quickly, which is why we say, be able to get the weather information as quickly as you can on your phones. Be ready to get out. Be ready to get out of town as quickly as you can when you get into these type of situations. And this is a good example of that. If you're not paying attention, kind of a hailstorm will come up on you like this, and these folks are having to get out and try to get to safety quickly. This is not an ideal situation, certainly, and please don't do this. Please don't do that. Getting under a little umbrella there. Try to get to cover quicker than these folks did. Certainly, this is not ideal for them either. But try to get to a safer situation a little bit quicker than these folks did. So again, rotating updraft can produce some very large hail for that same reason, because we do have that really intense updraft that's able to support larger hailstones. This is the Vivian, South Dakota hailstone from 2010. We'll talk about the tail of the tape on it. Diameter of 8 inches, a circumference of a little over 18 and a half inches, and about 2 pounds in weight, a little under 2 pounds in weight. No casualties with this, or significant injuries, I believe, but there was quite a bit of agricultural and crop damage that came with this. I guess the best thing is there weren't any significant injuries with this, miraculously. So we'll talk about damaging winds here. And again, if we talk about straight line winds, that's referring to damaging wind not only with a thunderstorm, just not part of a tornadic circulation. So it's basically wind coming out of our thunderstorm or outflow from a thunderstorm. So this can be from a downburst or from a squall line. So if I pour water on the table in front of you, it's not going to just stay in one spot and just behave where it just stays in one spot. It's going to run all over the table. It's going to run onto the floor. It's going to make a big mess. And the air behaves very similarly to the water. It behaves like a fluid. So once that wind impacts a single spot, the worst impacts are going to be where that wind initially comes down, but that wind is going to diffuse out, and it's going to produce further damage as it goes out. And that wind can produce, very similar damage to EF0, EF1, EF2 tornadoes because of winds in excess of 80 miles an hour up to 100 miles per hour with straight line winds. Now this is a downburst from Columbus, Ohio from a couple of years back. Watch the center of the screen in this picture, and you can just kind of see just a very intense downburst of the precipitation core coming down and just making a very quick and sudden impact. Right there, coming, boom, right there. Now, in this case, certainly the worst impacts are in the background, coming up right there. Hello, yep. So yeah, where that rain and hail is really making an impact is right there. But as the storm continues on, is not to say that wind isn't going to continue on and produce rain and wind for the rest of the area. Absolutely not. It certainly can. But the worst impacts are going to be where the rain is really falling right now. So when you see downburst damage, what it's going to look like is something like this, where you just have wind that is knocking down everything in a field, kind of like a field of dominoes, just kind of knocking it down kind of uniformly. And you're going to have what's called a divergent wind path with a downburst damage, because it's just going to knock everything down kind of uniformly. So with squall line winds, we tend to have them move quickly and can produce damaging winds over a large area. In this case, as you can see, we have a little blue line kind of moving out ahead of our storms. That tends to indicate that our winds are getting out ahead of our thunderstorms. And when that happens, our storms tend to weaken pretty quickly, because you have that forcing or the winds getting out ahead of our storms, which tends to get our storms weaker quicker. And that will typically spell an end to our storms a little bit faster than normal. So with a bow echo, you've probably heard this term, a bow echo, where basically if you think about drawing back a bow, an arrow, what happens at the apex of that bow, at the very front of that bow, you're going to have the strongest winds. So where you draw back the bow the most, right at the very leading edge of this bow, that's where you're going to have the worst potential for the worst wind damages at the apex of this bow. That's where your winds are going to be the strongest, typically. And we'll talk about, lastly here with wind damage, a derecho. Derecho is a very popular term that folks tend to kind of use interchangeably with squall lines, and that's not necessarily the case. In particular with the derecho, we do have a space component of that, or a aerial coverage component to that, where we need to have a damage swath of greater than or equal to 240 miles. So a pretty large area of wind damage that needs to be there for something to be correctly labeled as a derecho. It's going to form in unusually warm and moist air masses. In this case, the June of 2012 derecho, which honestly is a very unfair, very unfair example for derechos. This was a pretty intense, idealized example of a derecho, where it produced some pretty widespread damage from eastern Pennsylvania all the way down into northern North Carolina. And if you think about that day, we had temperatures in the low to mid 100s across the Richmond metro area, even down in the Norfolk. We had temperatures, in the low 100s that day as well. So at lunchtime, this line of storms was just coming through Chicago, and by 10 o'clock, these storms were rolling through the Richmond metro area and hitting Norfolk and Hampton Roads by midnight. So these storms were rolling pretty quickly, producing some very widespread wind damage. So the derecho and the squall line are not interchangeable. There is a space component to it, but the derechos do produce some very widespread wind damage when they do move through. So as a brief review, which is not true of our radar. Usually can't detect what's happening near the ground. Resolution decreases with distance. We at the Weather Service rely solely on our radar data when deciding to issue a warning, or Doppler radar can provide estimates of wind speeds inside thunderstorms. The answer is C, and that is why we're doing this class. So hopefully you're getting some information about this course, or through this course. Some flash flooding. Now certainly this is something that is a very severe and dangerous type of flooding, where we have rapid rises of water onto dry areas and rushing water over roadways. But water entering the main levels of homes and businesses, as well as any dam breaks that might occur. So this is a good example of flash flooding that moves through, as it moves through. Now, the force of a flash flood can move cars or even houses as it moves through. And as that happens, we do have the ability to issue what's called a flash flood emergency when we have situations with extremely high risk to life and property, or threat to life and property. As an example, in May of 2018, we had a series of thunderstorms that produced over 9 inches of rain in 2 hours over northeastern Maryland. And that produced a flash flood emergency over the Baltimore suburbs of Ellicott City in Maryland. And our friends up in Sterling, Virginia, actually ended up issuing quite a few flash flood emergencies for that particular storm. So just getting into the difference between the flash flood emergency and the flash flood warning. The warning is issued when a dangerous flash flooding is ongoing or will happen soon. Some roads will be flooded, homes and businesses may flood, and at that point the recommendation is to move to higher ground and don't drive through flooded roadways. The flash flood emergency is for those extremely rare situations when we have a severe threat to life and property. The only time you want to be traveling is when you're getting out of an area that is under an evacuation order, or if you are in an area that is subjected to that severe flooding and you need to get out of the way of it. Otherwise, certainly you need to get to higher ground as quickly as you possibly can. Now, the dangers of driving through a flooded roadway, hopefully are pretty obvious. We do say turn around, don't drown for that reason. You don't know what's going on underneath all of that water. So you don't really know whether there's a road surface under there. Next, with respect to urban and small stream flooding, this may require what's called a flood advisory or an urban small stream flood advisory, as we say here. The standing water on the roadways or streams running out of their banks. Typical flooding tends to be, those flooding of underpasses or flood-prone areas. These are not going to be your life-threatening flood situations. These will be, more run-of-the-mill, so to speak, flood situations where the more flood-prone areas get flooded, or the flood-prone highways and secondary roadways take on water. The water in these cases are going to be moving around simply because you have cars driving through them. Not going to be like we saw earlier with the flash flooding. This is just going to be kind of non-threatening flood type situation. Certainly you don't want to get into this water either, but these will typically not be your flash flood situations. So as a review here, when you're reporting to the Weather Service, should you always specify whether the water is standing or rapidly moving? You absolutely should. And if you have the ability to provide us a depth estimate, go ahead and do that, because that's very, very important to us to get that depth information if you have it, or if you're aware of the depth, go ahead and give us that information as well. Well, I thank you very much for taking our part 1 of our Skywarn training class. No 10-minute break required. We're going to go ahead and get started right now with part 2. Just go ahead and click the link for part 2, and we'll go ahead and get started with tornadoes. Thanks very much.